Have you ever just sat there trying to find the perfect words to get an AI to do exactly what you want? Well, it turns out you're not alone. That's actually one of the biggest challenges in the entire field right now. Finding the perfect prompt is this high-stakes, super expensive game, but what if an algorithm could just find it for us, automatically?
So let me just ask you this. How much do you think one perfect sentence is worth? You know, that one single prompt that unlocks the best performance from a top-tier AI. What's the price tag on that?
How about $300? Yeah, really. According to researchers, that's roughly what it can cost in just API fees to automatically fine-tune a single prompt for a model like Claude Opus. That's a staggering amount of money, and it basically locks most people out from ever finding the best way to talk to these incredibly powerful tools.
And you really, really want to get it right, because the stakes are huge. I mean, just look at this example from the research. With one prompt, the AI's accuracy on a math problem was, 43%. But with a slightly tweaked, optimized prompt, that accuracy jumped to over 79%. That is literally the difference between a product that fails and one that's a massive success. And it all comes down to a few words.
This really gets to the heart of the problem, what you could almost call the billion-dollar typo. The sheer cost and difficulty of finding that perfect prompt is a huge bottleneck for the whole industry.
Let's just break it down. Finding the best prompt right now is slow. It's crazy expensive, and it requires a ton of expertise. For developers and companies trying to build things on top of large language models, it's a massive barrier. And this is the exact problem a new research paper decided to tackle.
So let's meet the hero of our story, a brand new algorithm called CAPO.
CAPO stands for Cost-Aware Prompt Optimization, and its mission is simple: to automatically find those amazing 79% accuracy prompts, but to do it without that $300 price tag. The whole idea is to make powerful prompt engineering something that everyone can do.
Okay, so how does CAPO actually do it? What's the secret sauce here?
Well, the magic of CAPO isn't some totally new invention from scratch. Instead, it's this really clever combination of three powerful, battle-tested ideas that come from the world of automated machine learning, or AutoML.
So first, it uses what's called an evolutionary approach. Think of it like survival of the fittest, but for sentences. Prompts compete with each other, they crossbreed to combine their best parts, and they mutate to create even better versions. Second, it uses a really smart cost-saving trick called racing to get rid of the bad prompts fast. And third, it does this multi-objective balancing act. It's not just looking for the best prompt, it's looking for the one that's also the shortest and cheapest to run.
Let's dig into that racing idea, because it's where a lot of the savings come from. Imagine you're running a Formula 1 race. You wouldn't let every car run all 50 laps, would you? Of course not. You have qualifying rounds to drop the slow cars early on. Well, racing does the exact same thing for prompts. It tests a bunch of them on a small amount of data, and if a prompt is clearly not doing well, it's cut immediately. This saves all that time and money for the real contenders. It's so clever. Okay, so the theory sounds fantastic, but does it actually hold up in the real world? Well, the researchers put CAPO to the ultimate test.
They pitted it against other state-of-the-art methods, algorithms with names like EvoPromptGA and OPRO. The goal was simple: who can find the best prompts, the fastest, and for the least amount of money?
And wow, the results are just dramatic. Take a look at this first graph. On the vertical axis, you've got performance. Higher is better. On the horizontal axis, you have cost. Further left is cheaper. Now just follow that bright green line. That's CAPO. It starts higher and it climbs faster, getting way better results for just a fraction of the budget. It's not just winning, it's playing a totally different game. But pure performance isn't the whole story, right? This next chart shows that second goal, efficiency. Again, performance is on the vertical axis, but this time the horizontal axis is prompt length. Remember, shorter is cheaper. Now look where the best prompts for each method end up. They're marked with stars. See CAPO in green? It finds prompts that are super high performing and they're pretty short. Now look at some of the competitors, like that pink one. Sure, they find good prompts, but they are incredibly long, which would make them way too expensive to use in a real product.
Okay, so CAPO is clearly great when you give it a decent place to start. But what happens if you feed it total garbage? You know, for a system to be truly great, it has to be robust. Can it actually recover from a really bad start?
And this graph is where CAPO's resilience is on full display. In this test, both systems were fed generic, basically useless starting prompts. Look at CAPO in light green.
It figures things out, it recovers, and it climbs right up to a top-tier score. Now look at its competitor in that little purple inset box. It just flatlines. It gets completely stuck. This shows that CAPO is robust enough to find its way to a great solution, even if you started off in a terrible spot.
So, after seeing all these results, what's the big picture? What does this all really mean? Let's quickly break down the key takeaways.
So, the bottom line is this. CAPO is a clear winner. It outperformed its competitors in 11 out of 15 different scenarios. That racing trick we talked about, it's incredibly effective, saving up to 44% of the evaluation costs. The paper also drives home that including a few examples in your prompt is absolutely crucial for complex tasks. And as we just saw, the system is tough enough to handle really bad starting points.
You know, all of this research leads to a really fascinating question. Maybe the future of AI isn't just about building bigger and bigger models. Maybe it's about developing smarter, more efficient ways of talking to the models we already have. And if you ask me, CAPO suggests the answer to that is a resounding yes.
Breaking down these kinds of complex, cutting-edge papers is exactly what we love to do here.
We really hope this gave you a clear look at the science that's shaping our future. If you want to understand the research that's building tomorrow's AI, make sure you subscribe to VibeDoc on YouTube for more explainers just like this one. Thanks so much for tuning in.